Okay, so we're back. This time we're going to be going over some asymptote problem examples. Okay, just to kind of give you guys a better understanding of asymptotes, I'm going to go over some of the problems that you might see on the next test. Okay, for this first one, we're going to start off nice and easy with just f of x equals 1 over x. We kind of saw this example twice before already. We're just figured great place to start just in case you didn't see the other two examples. So we're going to start with this, this function right here. Okay, for the vertical asymptote, if you remember from the last video, you should check your notes on that from the last video if you didn't. To figure this out, you need to set d of x in the rational function equal to 0. Okay? The d is the denominator. So here's our rational function right here. The denominator is x. Okay? So d of x is equal to x, and we have to set it equal to 0. Well, this problem is pretty much done for us already then because it's just x equals 0. That would be the line, which remember asymptote is a line with the equation x equals 0. That would be the asymptote for this problem, x equals 0. So that one's nice and easy. The other ones that we're going to see are a little bit harder, but we're just going to start off easy on this first one. So x equals 0. Okay, the horizontal asymptote, if you remember from the last video, by definition, you have to do the limit of the function, in this case 1 over x, so I'm just going to put 1 over x in here, as x goes to infinity. Oops. Just a little sloppy here. As x goes to infinity. Okay? And as you can see, you're dividing by a bigger and bigger and bigger and bigger and bigger number. If you divide by a bigger number, you will approach but never actually reach 0. So the limit of this function 1 over x as x equals infinity would be 0. Okay? And it's y equals the limit of f of x as x goes to infinity. So the equation would be y equals 0. Okay? So those would be your two answers, the vertical asymptote and the horizontal asymptote. That's the easy one. Let's go to a harder problem that you're definitely going to see a problem like this on the test. Okay, the vertical asymptote, again, you just solve d of x, its denominator, set it equal to 0. Okay, so I'm going to actually just substitute this in here, just like I did on the first one. All right, equals 3x squared minus 3. Okay, there's two ways that you could solve this. Well, there's a handful of ways, but two main ways. You can either use the quadratic formula if you want, or you can just use strict algebra. I'm going to use algebra on this, but remember, sometimes you're going to see these quadratics in the denominator. Don't be afraid to use the quadratic formula. It's perfect because it's already set equal to 0. It works great. Okay, for here I'm going to get rid of this 3, add 3 to both sides. I'm going to get 3 is equal to 3x squared. Okay, I'm going to cancel off this 3, divide by 3 on both sides, that's canceled. You end up with 1 is equal to x squared. Okay, to get rid of the squared, you want to do a square root. Make sure you make it plus or minus though. Every time you square root, it can be plus or minus, because if you square a negative, you get a positive. If you square a positive, you get a positive. Okay, square root of 1 is 1, so the answer should be x is equal to positive and negative 1. Okay, so this time you have two vertical asymptotes, which is totally okay. Okay, and this would be your answer right here. X equals positive and negative 1. Okay, next we're going to do the horizontal asymptote. Remember, by definition, it's going to be y is equal to the limit of this whole function right here, this 2x over 3x squared minus 3 as x goes to infinity. Okay? Now, whenever you see a problem like this, you should know, okay, x is going to infinity. That means it's 2 times this x is going to infinity. This 3 in the x squared, that's going to infinity. This 3 is not, there's no x involved in it, okay? There's no x whatsoever. So this 3 is essentially meaningless when we talk about going to infinity. All right? 3 is just kind of left in the dust. It's not that important. Okay, 3 is not even that important of a number compared to, you know, if we got to 1,000,000 or 1,000,000,000 or 1,000,000,000. This is going to infinity, so it's even going further than that. So that's 3. I'm just going to put kind of a line to it. We're done. We don't care about it. Okay, it's meaningless because we're going to infinity. So that means that we have 2x divided by 3x squared. Now this simplifies to 2/3, 2 over 3, and then x divided by x squared is just, these x's cancel and you end up with just an x on the bottom. So it's 2 over 3x. But this x is going to infinity. So it looks really, really similar to the problem we had before where it was 1 over x. This x kept going, getting bigger and bigger and bigger. So essentially you're dividing by a bigger, bigger, and bigger number. Okay? So since we keep dividing by a bigger and bigger number, this would essentially be 0 just the same. Okay? Because x is going to infinity right here, it would be 0. So in this case, our horizontal asymptote would be y is equal to 0, just like the first one. Okay? I know it looks different because it's not 1 over x, but you're still dividing by a bigger and bigger number. So it would be 0. So the verticals, there's 2, and the horizontals, there's 1. Okay? Last one. H of x equals this whole mess right here. Now, the vertical asymptote, again, all you have to do is set the denominator equal to 0. So I'm going to write d of x equals 0. And this denominator is x minus 4, so I'm going to put an x minus 4 in there. You should be able to solve this in your head. Add 4 to both sides. X is equal to 4. Done. That's your vertical asymptote. Okay? It's not always as complicated as this. It doesn't have to be. Okay? Slant asymptote. Okay? Whenever you see a problem where the degree is higher on top, on the numerator, compared to the denominator, you're always going to have a slant asymptote. That's a good rule of thumb to follow. Okay? Now, if you wrote horizontal, that's okay, because toward the end you're going to get an equation. You're going to know it's a slant asymptote anyway. You would just have to make sure you change it for the exam to make sure you get it completely right. So what we're going to do is, it's set equal to y is equal to the limit as this whole thing goes to infinity, with x going to infinity. That looks like an 8. We don't want that. As x goes to infinity. Okay, if you remember from last time that 3 was meaningless, this 4 is meaningless as well. Okay, so you can kind of simplify this down by factoring out this x right here. So you would end up with 4x, because it's x squared divided by x, to get x. And then plus 2x, this 2x divided by x would just be 2. Okay, so you're left with this equation right here. 4x plus 2. And this is why it's a slant, because 4x plus 2, if you remember from Algebra 1, it's just a line. Okay? So if you actually graph this and graph this, you'll notice that the line perfectly matches up with what the asymptote is for this rational function. Okay? So all you would write down for the slant asymptote is y is equal to 4x plus 2. That would be your slant asymptote for this problem. Again, if the degree on top is bigger than the degree on bottom, you're going to have a slant asymptote. Okay? If you have any questions on any of these examples, let me know, and I hope that helps. Later.